We are looking at the practice number 9 sheet. At this time, you should have done just the last two questions, the energy questions at the bottom. I assume that you've already given these a try. If you haven't, please pause the video and do it at this time. The given variables and their units will be the mass being 4 kilograms, the velocity being 4 meters per second. Please do not have the word mass here or the word velocity. It's asking you for the variables, and so we want just the letters. In this case, it's kind of obvious, but in other cases, the letters are different than the words, and so we want to make sure that you understand which ones go where. Okay, so you also have to have the units, kilograms and meters per second. The desired variable in this case is we want to find out how far it fell, so that is the h. If you wanted to have a y there instead, that works out fine too. The raw equation. We start off with the idea that the potential energy is equal to the kinetic energy, U sub g for potential gravitational energy. But if you want, you could write down the phrases for each one of those, mgh for the gravitational energy, and 1/2 mv squared for the kinetic energy. Substitutions. The 4 comes down for the m. 9.8 is our constant for the gravitational acceleration, and then the h is the unknown we're looking for. The m again is 4, and another 4 for the velocity. When you do your calculations correctly, you should get 0.816 meters. Don't forget the meters part. If you don't have the unit, you're not going to get all your points. Okay, the last question on this page. A student takes 3 seconds to lift a 2-kilogram box up from the ground to a height of 1 meter. Find the student's power output. If you've not yet done this problem, please pause the video and do it now. The given variables, we have the time, t is 3 seconds, the mass of the object is 2 kilograms, and the height is 1 meter. The desired variable is a capital P. Small p stands for momentum, and a lot of people chose the small p for the raw equation. They said p equals mv, and that would be wrong. We want the capital P, and there are different versions of this. The general idea is power is the change in energy over time. It's the rate of changing energy. In this situation, we have gravitational potential energy changing, and so I could write, instead of the delta V on the top, I could just write the mgh. That's how much extra energy it gets as we lift it from the ground. Substitutions then. The power equals 2 for the mass, 9.8 for little g, 1 for the h. And that is divided by the 3 seconds. We get an answer of 6.53 watts. Don't forget the watts. That's the power, sort of like the power of a light bulb is rated in watts. A lot of people were using J for joules in the past. That's wrong. That's the energy. That's just the top part, E. We have E divided by T, which will be watts. Some people put newtons, capital N. That's for force. So make sure you have the right units, please. Okay. Please go on now to practice number 10 and do the bottom 2 problems there.